Today we'll be looking at arithmetic progression. The first question which comes to my mind is, what is a progression? Progression refers to the act of progressing, that is moving from one element to the next element in a systematic manner. A sequence can be termed as progression when there exists a certain relationship between its terms. There are three main types of progressions: arithmetic progression, geometric progression, and the harmonic progression. What is arithmetic progression? A successive progression in which the difference between any two consecutive terms is constant and is independent of the position of the term. Or in other words, we can say the difference between the term and its preceding term is always a constant. If we take any two terms, irrespective of their position, the difference between the term and its preceding term is always a constant. Let's see an example. 1357 is an arithmetic progression. Let's see how the 1357 is an arithmetic progression. The first term in this sequence is 1. The second term is 3. If we take the difference between the second term and the first term, that is 3 minus 1 is equal to 2. If we take the difference between the third term and the second term, 5 minus 3 is equal to 2. We take the difference between the fourth term and the third term, 7 minus 5 is equal to 2. So we see, irrespective of the position, if we take the difference between the term and its preceding term, if it is constant all throughout the sequence, then we can term it as the arithmetic progression. So 1357 is an arithmetic progression. Minimum, how many terms are required to judge whether a sequence is an arithmetic progression? Suppose if we are given the numbers 1, 3, can we predict the next number? We can't, because we are not mentioned that it is an arithmetic progression. What will be the common difference? With only two terms we can't predict whether the sequence is an arithmetic progression. We need at least 3 terms to predict whether the sequence is an arithmetic progression. If we generalize our arithmetic progression, we consider the first term as a. The common difference, the difference between the term and its preceding term is d. The number of terms is n. Then our progression becomes a plus d, a plus 2d, a plus ad, up till a plus n minus 1 d. This forms an arithmetic progression. The nth term of our AP is a plus n minus 1 into d. Let's see an example. The first term of an AP is 5 and the common difference is 3. Then the 20th term in the progression will be, we have to find the 20th term in our arithmetic progression. So the first term, that is equal to a is equal to 5. The common difference d is equal to 3. We have to find the 20th term. 20th term. We denote it by T20, that is term 20. T20 will be is equal to a plus n minus 1 into d. The n is 20, that will be equal to 20 minus 1 into d. 5 plus 19 into 3, that is equal to 62. Now if we have to find the sum of arithmetic progression, that is a plus d, a plus 2d up to a plus n minus 1d, we have to derive the formula for this relationship. First of all, let's see some of the important arithmetic progressions which we commonly come across in mathematics. 1, 2, 3, 4, 5. What is this? This is the first n natural number sequence. This is the arithmetic progression with the common difference of 1 and the first term as 1. If we take the first n odd numbers like 1, 3, 5, 7, 9 up to 2n minus 1, the first term is 1 and the common difference is 2. A is equal to 1 and the common difference is 2. Now if we have to find the nth term of the sequence, the Tn will be is equal to a plus n minus 1 into d. The value of a is 1 and value of d is 2. That is equal to 2n minus 1. Similarly, for the first n even numbers, the first term is 2 and the common difference is 2. The nth term will be equal to 2n. Let's look at more examples. Now we have to find the sum of first n natural numbers. We have to find the sum of first n natural numbers, 1, 2, 3, 4, 5 up to n. So if we write 1 plus 2 plus 3 plus up to n minus 1 plus n, we have to find the value of s, the sum of first n natural numbers. If we write s in a reverse order, we'll write n first, then n minus 1, then n minus 2, and this will go up till 2 plus 1. If we add the first and the second equation, we'll get 2s is equal to n plus 1 plus 2 plus n minus 1 is equal to n plus 1, 3 plus n minus 2 is equal to n plus 1, and up till last as n plus 1. So we'll be getting 2s is equal to, how many times these are? There are n terms, so n into n plus 1. S is equal to n into n plus 1 by 2. The sum of first n natural numbers is n into n plus 1 by 2. Similarly, we can find the sum of first n odd numbers. What will be? S is equal to 1 plus 3 plus 5 plus 7. What will be the nth term? That will be equal to 2n minus 1. We write the sum again in the reverse order. That is 2n minus 1 plus 2n minus 3 plus 2n minus 5 up till 1. If we add both these equations, we'll get 2s is equal to 2n minus 1 plus 1, that is equal to 2n plus 2n plus 2n up till 2n, right? 2s is equal to, how many terms are these? N terms, n into 2n. So we get the sum of first odd n numbers. Sum of first odd n numbers is n square. Similarly, the sum of first n even numbers, that is equal to, s is equal to n into n plus 1. We can find the formula in the same way. Sum of n terms of an AP whose first term is a, the common difference is d, and the nth term is a plus n minus 1 into d. Let's derive the relationship. S is equal to a plus d, a plus 2d up to a plus n minus 1 into d. So we have to find the value of s. If we take all the a terms together, a plus a plus a, how many times will it be? N times, plus d 1 plus 2 plus 3 up to n minus 1. The value of s will be equal to na plus d. The sum of first n minus 1 natural numbers, what will its value be? N into n plus 1 by 2 is for the first n natural numbers. For n minus 1 will replace n by n minus 1 in the formula. That will be equal to n minus 1 into n upon 2. What will be getting? If we take n by 2 as common, then we'll get 2a plus n minus 1 into d. Sum of n terms of an AP is equal to n by 2 into 2a plus n minus 1 into d, where a is the first term, d is the common difference, n is the number of terms in an AP. Looking for more examples, the example 1, the sum of first 13 terms of an arithmetic progression is 21, the sum of first 21 terms of an arithmetic progression is 13. Then we have to find the sum of first 34 terms. So the formula for the sum of first 13 terms, that will be equal to, if we say it as 13, that is equal to n by 2 into 2a plus n minus 1 into d. N is equal to 13, that is equal to 13 by 2 into 2a plus n minus 1 into d, where n is 13 minus 1 into d, that is equal to 21. Sum for 21 terms as 21 is equal to n by 2 n is 21, 21 by 2 into 2a plus n minus 1 to d. N is 21, that is equal to 21 minus 1 into d is equal to 13. Let's term this as equation 1, this as equation 2. Right? The first equation will be 2a plus 12d upon 2, that will be equal to a plus 6d is equal to 21 upon 13. The second equation will be 2a plus 20d upon 2, that will be a plus 10d. A plus 10d is equal to 13 upon 21. From this equation we can find the value of a and d. Solving this, we'll get a is equal to 849 upon 273, and the value of d will be equal to minus 68 upon 273. Taking on the next example, if we are given the sum of p terms of an arithmetic progression is ap plus bp square, then what will be the value of fourth term? The sum is equal to ap plus bp square, and the number of terms are p terms. The total number of terms are p. Right? So if we write the general equation of an AP, S is equal to a plus d till a plus n minus 1 into d. Right? So we can write this as sum of n terms, that is Sn is equal to sum of n minus 1 terms, Sn minus 1 plus nth term. Right? So we'll get the nth term is equal to Sn minus 1, where Sn is sum of n terms and Sn minus 1 is sum of n minus 1 terms. Right? Now we are given that the Sn, sum of p terms, is equal to ap plus bp square. So if we have to calculate the value of the nth term or the pth term of this series, the Tp will be equal to Sp minus S of p minus 1. S of p minus S of p minus 1. Sp minus Sp minus 1, that is equal to Tp. So Tp will be equal to, the sum of p terms is ap plus bp square. P minus 1 will be ap minus a, that is a into p minus 1 plus b into p minus 1 square, that is equal to ap plus bp square minus times ap minus a plus bp square minus 2bp plus b. Cancel, ap could be cancelled, right? Bp square could be cancelled. What we get is a